Wind turbines come in many different shapes and sizes. This is a turbine that actually has a vertical axis about which it spins. These types of vertical axis wind turbines are a little odd to see because it's not how we normally picture them. But they can generate electricity nonetheless. Here's one spinning with 3 different blades moving around. Here's another wind turbine with a different vertical construction, but it still rotates about a vertical axis. More commonly, we think of wind turbines using the horizontal axis model, so these are 3 blades that spin around a horizontal axis like this. Regardless of which type you use, there is one equation for the power that the wind carries. A is the area of the blades, which is pi r squared for the simple case of a horizontal axis. Rho is the density of the air, and v is the speed of the wind, or the speed of the air. This equation represents a maximum value of power that the wind turbine could extract from the air. In fact, this isn't quite correct because it's impossible to ever reach this maximum power that the air contains. Why can't the turbine extract all of the air's energy and power? It turns out there's a very logical reason why the wind and the air cannot give all of its kinetic energy to the turbine. Watch what happens. The wind comes in with a very high speed, so it has a lot of kinetic energy. It transfers some of that kinetic energy to the turbine, and the turbine starts to spin. But the wind moves beyond the turbine, and it still is moving over here. So the wind retains some of its kinetic energy. The wind cannot give all of its kinetic energy to the turbine, because if it did, it would just stop in its tracks, and no more air could pass through. So the wind has to keep moving so that more air can flow. Therefore, it cannot give all of its kinetic energy away. It has to retain, the air has to retain some of its kinetic energy. And as a result, this power that the air carries cannot all be transferred to the wind turbine,